Hello everybody, welcome to the final video for Precalc section 3.3, Notes, Properties on Division. In this video, I will be going over the zeros of a polynomial if you already know a zero for the polynomial. It turns out not every polynomial you look at seems like it's immediately factorable. However, if you know a zero of a third degree polynomial, you can find the other zeros. And just for ultra transparency, here's the definition of a zero. This includes real or complex numbers as far as zeros are concerned. I will go into a little bit of nuance with that as I finish the first example here. I want you to know that you'll be given real zeros, but that doesn't exclude complex, aka imaginary, zeros. And just to keep it fresh in your mind, hope you remember the quadratic formula. May show up. All right. Find all the zeros for this particular function if you know this is a zero already. Now, one thing you want to know about this being a zero is that, yes, it does make the function equal zero when you substitute it in, but just like I had shown with the synthetic division, if you use that value in synthetic division, that will be much more helpful this time around because we will know what the result is after dividing. So set up the synthetic division. We have bring down the 2 times negative 3 is negative 6 is negative 11 is just 33. When you add those together, you get 12 times negative 3 is negative 36, which is 0, just like it should be. And the fact, again, that it is a zero is telling you the remainder is 0. So we know, I'm just going to start this answer over here, x equals negative 3. These are the zeros for the polynomial. From there, what needs to happen is you need to interpret your answer. So you have 2x squared minus 11x minus plus 12. Now, from this point, I don't care how you get the answer. Just get the answer. You can use the quadratic formula if you want to. However, this one factors. So what I will do is I will show the factors for that now. This would be a minus 4 minus 3x. There we go. And you can set each of these factors equal to 0 and solve for x. So that'll give you x equals 3/2 and x equals 4. Now both of these are also zeros for the polynomial. And this is all of them because you can only have as many zeros as the degree. Or at least as many different zeros as the degree. So we need 3 answers. We have 1 that was given to us, 2, 3. Okay, one other thing here I want to point out is that you may be asked to factor a polynomial completely. In that case, what you can do is first notice that if this factors, then you should factor it. And you can see these are 2 factors of this polynomial. And you can test that yourself. You can substitute the answers you get from these factors, the 3/2 and the 4. Put those in here for all these x's, and you should get 0. Now, the factors here, this factor gives you 3/2, this factor gives you 4. What factor gives you negative 3? That is clearly an answer. That also was given to you. Well, if you take the x equal to negative 3 and you solve it for 0, meaning you need to get a 0 on one side, then you can see the other factor is x plus 3. So f of x can actually be factored here to x plus 3 times 2x minus 3 times x minus 4. And this goes back to what I said back here. It doesn't look immediately factorable. When you take a look at this polynomial, you can't just tell it does this. So we give you a little help. You find what the answer, you factor it, or maybe use the quadratic formula to find the other answers, and you're on your way. For this example, you can see we're still trying to find all zeros for the function here, except in this case, we have a factor of the function. And in fact, this is the wrong factor. This should be 3x plus 2 is a factor of that function. And if it's a factor, that means the corresponding zero it produces, if you set it equal to 0 and solve for x, is a 0 for the function, which means if we come over here and set up a synthetic division for this function, then we can get a remainder of 0. So how do we do that? Well, we bring down the 9, and we can take negative 2/3 of 9. Well, 2/3 of 9 is 6. Positive times negative is negative. Don't forget your 0x squareds. As you can see, they are missing in the function. So we can add the 0 and negative 6. Negative 2/3 of negative 6, well, negative times negative is positive. 2/3 of 6 is 4, leaving you with a negative 45. And then lastly, negative 2/3 of negative 45 is a positive 30. And that does guarantee the 0 here. So we knew from the beginning, with a little bit of work, that x equals negative 2/3 is a 0. And now we have this polynomial down here. And if we wanted to interpret that, that would be 9x squared minus 6x minus 45 equals 0. Now, something very briefly about this polynomial is that this isn't actually what you get when you divide by negative 2/3. Right, this negative 2 or this 3 here kind of throws off the polynomial a little bit. You can tell very easily that when you multiply this factor times this factor, you should get 9x to the 3rd power. So when you do that, you get 3x times 9x squared gives you 27x to the 3rd power. What happened? Well, it has to do with this divide by 3 in the divisor. So in order to get the correct polynomial, you will need to divide all of these by 3 to give you the new polynomial 3x squared minus 2x minus 15. And I guarantee if you take this divided polynomial and multiply it by the factor we were given, you will get exactly this polynomial that you started with. And that's just a little bit of a glitch when you have a coefficient in front of x. Okay, so whatever is divided by here, unsimplified, you'll have to divide by here. Okay, so now though, we can try factoring this, and let's see, will this factor? It doesn't seem to factor, so let's quick use the quadratic formula. That will be x equals negative b plus or minus b squared minus 4 times a times c, all in a square root, all over 2a, so 2 times 3. So that means I will have a 2 here and a 6 down here and a plus or minus something. When you take the time to simplify all of this stuff in here, I think you'll end up with 184. I'm forgetting a negative sign right there in front of the 15. All right. Yeah, you'll get 184. And when you simplify the square root of 184, you end up with 2 plus or minus 2 radical 46 all over 6. And there is one final simplification that needs to be done here. Since all of these numbers outside can be divided by something in this case 2, do it. Divide them all by 2. And what that will leave you with is a 1 plus or minus root 46 all over 3. And these are the other two zeros for this function way back here. Again, we could look at the factors, and because this function here does not factor, we could write f of x like this. I'm just going to write this above it. We could write it like f of x equals 3x plus 2, that's the factor that was given, times 3x squared minus 2x minus 15 from right here. And that's it. Since this does not factor anymore, this is the factored version. All right, let's take a look at example 3. A little bit of a speed run maybe. We know we're finding the zeros. One of the zeros is -4. So go ahead and pause the video. I'll come back in, 10 seconds and have the solution, all of it, right down on the page. I lied. I have some things I want to say as I go through this last little bit here. Anyway, most of the example is here. So we have finding all the zeros. I took this 0 and put it in the corner, set up the synthetic division, did the synthetic division, interpreted the answer, and I'm starting to solve for this x value here. So yeah, we can solve for this by subtracting 25 and taking the square root. Don't forget your plus or minus in front of the number. And we're right here, x equals plus or minus -25 in a root. The way to simplify this now is to take the negative out of the square root as an I, and of course you want to simplify the radical, kind of like we did in that last example there. But the square root of 25 simplifies so easily right to 5, so we get these two answers, x equals plus or minus 5i, and then a 0 all the way back over here, x equals -4. So zeros can be imaginary or complex. And the factors of this function up here, f of x, kind of function like the last example. We could write x plus 4 because that's what you'd get if you solved this factor, or this 0 for 0. And then the other factor is right here. This does not factor. So the only other factor we have is x squared plus 25. And if you multiply all this out, you'll get what's here. A couple other things I want to point out. Imaginary zeros always come in conjugate pairs. That means there will always be an even number of imaginary or complex zeros. There will always be. One version will have a positive imaginary units, the other one will have the negative imaginary units. I think that's it for this, because the next set of notes will go a little bit deeper into how to find zeros of polynomials using the rational zeros theorem. See you all in the next one.